Okay, uh, so in the previous tutorial we have seen how we can set up our idle stance animation dynamically by using our idle anim variable. And now I want to make this ABP locomotion system independent from this sort of manual initialization of the variables, which means that let's say if I have a data table of each and every individual animations, for example this idle animation, then by referring the data table, this ABP locomotion and in blueprint should be able to play that specific animation for us. Okay, so that's what we are going to set up today. And yeah, this is bit interesting one, right? Okay, so let's start with very basic stuff. Okay, so first we need to create a component as a subsystem actually. So I'll create folder called components, and there you can create a blueprint actor component, and I'll name this as BPC. Yeah, let's name this as BPC Locomotion system. Okay, so the benefits of having this sort of a actor component is that we can plug this actor component to any specific actor, right? For example, let's say we need to drive our character animation locomotions, then we can simply plug this actor component to that specific character base. And maybe let's say we have sort of an animal blueprint instance, again we can plug that specific blueprint actor component there as well, right? So it's sort of a pluggable architecture that we can easily plug and play our animations for a specific character. Okay, so now we can go to our BP character base and let's attach this BPC locomotion system there. Okay, so currently it is an empty one. There are no specific configurations rather than the default ones, but yeah, this is the first thing that we need to do. We just created the blueprint actor component and attach it to our character. So just to test that thing out, I can simply print a string, and if I play it, you can see it's printing this specific print string. Okay, great. So we don't need to do such a naive thing, so I'll just remove that print statement, and instead of that, let's create let me quickly look at my documentation. Yeah, then let's create a data table to store our animations. Okay, so first I'll go to TPS game folder and create a new folder called data, and there I'll need 3 folders. One thing stand for data table, and one folder for structs, and another one for the folder for enums. Okay, and then inside this struct folder, maybe we can create a what do you call the very first structure, data structure, and I'll be having a lot of data structures for each and every individual components and maybe actors. Therefore, just to organize our data structures, I will organize this different stuff into different folders. So it will be easy for us when we are scaling our game. So I'll name this as Locomotion, and inside there I'll create a new blueprint structure, and I'll name this as sanim set, right? So S prefix stand for structure. Okay, and I'll open that thing, and there I'll create a variable or field called idle, and this one is using anim sequence as its data type. Okay, so I'll keep the default value as empty because once we created our data table, we can quickly set these values there. Okay, now let's go to the data tables folder, and there again I will create a new folder called Locomotion, and I'll create maybe a data table under the miscellaneous data table, and there you have to select a specific record structure. So that's why we create the separate data structure like sanim set, because we can use it as a generalized row structure for our data tables, Locomotion data tables. So I'll choose sanim set data structure and click OK, and I'll name this as dt anim set. Okay, and I'll open that thing out, and there now you can see we can add records by clicking this add button. So I'll create a new record like this, and I'll maybe name this as unarmed. Okay, and then now I can assign our unarmed idle break animation, but I will use this unarmed idle ready animation because this mf unarmed idle ready stand for female animations, and this stand for mannequin male animations. So for now, as the prototyping, I will use these male animations, and later on we can extend our anim set for the female characters as well. Right. So for now, I'll simply select this unarmed idle ready and save it. Okay, now we have this data table initialized with our idle ready animation. Okay, then as the next step, what we need to do, we need to set this data table, or we have to take this data table to our BPC locomotion system, right? So I'll create a new variable called maybe anim set data table, and its type should be data table. Okay, and I'll select our dt anim set data table here as well. Okay, and I will be having multiple different anim sets such as maybe unarmed and maybe pistol, maybe rifle, sword, things like that. So in order to distinguish that specific row name, I will create another variable called maybe anim set name. and it should be the type of name, and by default value should be unarmed. Okay, so I'll make these variables public and I'll group them in this setup category. Okay, now you can go to a BP character base and click on this BPC locomotion system. Now you can see those variables has been publicly exposed within this specific actor as well, right? So if you want, you can tweak these values later on, but right now we have these default values as the initial step. Okay, then let's go to a begin play, and I'll remove this tick function for now, and I'll add a sequence, and let's say after like sort of a delay, because maybe it will make some rest condition later on when we have more and more animations. So in order to prevent that, I will add a small delay, and now I need to set this anim set based on our anim set name provided here. So maybe I'll move it bit up like this. Okay. Yep. Give me a second. Okay. So I'll create a new function called set anim set, and there I need to consume anim set name, which is a name, and I'll promote this to a local variable l anim set name, and then I can maybe create an event dispatcher to trigger this specific function at our locomotion blueprint. So what is the goal of this function is like, whenever we set our animation, automatically it should trigger an event to make that changes at our ABP locomotion anim instance as well, right? So in order to make that connection, there are several approaches that we can follow. Either we can make a interface call, or we can make a direct casting to this specific locomotion instance, and the next approach is using a event dispatcher, right? So event dispatcher would be the ideal solution for this sort of a scenario, because it ideally dispatch events when a specific invoking happens. So let's add the event dispatcher, and I'll name this as event on set anim set. Okay, and here it should consume an input that signifies which is the anim set that we currently have, right? So I'll make an input called anim set and compile and set. And now inside this specific function, let's call that event dispatcher, and I'll pass this local variable to that specific event dispatcher. Okay, so I know this seems pretty much naive for now, because we are consuming this anim set and we are simply passing it to here. But later on you will see, when we are scaling our locomotion system step by step, these functions will get populated, and having this sort of a generalization would be helpful for us at the later part of the tutorial. Okay, so now let's call this function here at our event graph, set anim set, and I'll pass this anim set name global variable to there. Okay, now at the begin play, it's simply initializing these variables and make a event dispatch call here. Okay, now what we have to do is we have to listen to that specific event at our ABP locomotion, right? So for that, what we can do is we can go to this event graph, and instead of using this event blueprint update animation function, because this function is calling for each frame, which is very expensive task, but we don't need to call this initialization for each stage. We only need to call it once at the initialization. Therefore we can use begin play function, plus for the safe side, let's call the blueprint initialization animation function as well, right? So at most it call 2 times for the initialization. Okay, and then I'll create a new function called maybe initialization, and inside this function, now we have to listen to that specific dispatch event. But for that we need to have a reference for this specific blueprint locomotion system. So let's add those stuff now. So I'll add a sequence, and first let's get try get for known, and if this is valid, I'll make this as POW. And maybe the category could be references. Now comment this thing as get on ref. Okay, and then by using that form, let's cast to character, and let's have a reference for that character instance as well. I'll group into this references group, and let's get the character movement, for instance, now, because we need to reference this specific variable multiple times later on, especially when we are moving our characters at our level. Therefore I think it would be much easier to make a reference for this character movement as well, right? Then our code will be much cleaner. So I'll make another reference called character movement, and by default it is being attached to this components category, which is fine, I believe. And I'll comment this thing as get character and movement component refs. Okay, and now we can get our pawn and get component by class, or even we can use the character and get component by class, our component could be BPC locomotion system. So simply what we are doing here is we are checking whether this specific actor has attached component called BPC locomotion system. So if it is has such a component, I'll promote it to a variable called BPC locomotion system, and I'll plug it like this, and we need to initialize this only if is not valid, right? So I'll add this is valid filter, and if it is not valid, it will initialize it, otherwise we can continue. Okay, and if this one is valid, then we are good to continue, right? So if it is valid, we can continue, and if it is not valid, we can't continue. Therefore I will return from this function, right? Then it won't go to the next initialization stages. Okay, so if it is valid, it should continue at the next step of the sequence onwards, which is here, right? But first I'll comment this thing, so later on when we are referring the code, it will be much easier to understand what we have been done. So I'll name this as get locomotion component, and yeah, and then actually maybe we can print string and see whether this initialization works. So if it is initialized properly, we should have a reference for this BPC locomotion system. So I'll display its name for now, and yeah, we'll see. It's not printing, probably because I haven't called the function here. So let's call the function first, and let's play it again. Now you can see that reference is printing, which means like we did here, it is referenced properly, right? Okay, now the reference is there, but our intended goal is to listen for this specific event on set anim set dispatcher event. So let's do that now. So I'll use this BPC locomotion system reference to call our delegates or even dispatchers. So I can simply search for I think set anim set, and make sure to use this bind event to event on set anim set delegate. Okay, so now actually we are listening for this specific event dispatcher, and whenever this event dispatcher has been called, it should trigger a specific event or a function call. So for the simplicity, I will use a create event, and here you can see either we can create a matching function or create a matching event, and maybe I will create a matching event for now, and I'll name this as the same name, which is event on set anim set. Okay, and maybe I will create a new event graph called Locomotion event graph, and I'll move that event to there. So our code is bit organized, and if I jump back to the initialization function, you can see it is showing an error because I have moved the function to there and the reference has been breaked. So I'll select it again, which is this event on set anim set, and I'll compile it again. Now the error has been gone. Okay, And then whenever this function or an event is called, it should trigger this event, and I'll promote this to a variable called maybe ls underscore anim set name. So let's stand for locomotion system, and I'll group it to a category called locomotion system. Okay, we have that variable here, and then what we can do is we can get our locomotion system, and we need to take that specific data table record by using this specific anim set name. So in order to do that, I think we can maybe create a helper function. So I'll go to the BPC locomotion system and create a new function called get anim set. So there I'll get the data table row for this specific data table anim set. So I think there is a workaround for these things, and I think it's a bug in the UE5, which is if I select this data table and compile, you can see this out row is a wildcard value. But what we need to do is we need to have a specified data structure here, right? So in our case, it is anim set. So I have seen in order to resolve that issue, first we have to manually bind our data table here and compile it. So now that out row is been populated with this specific anim set, and then we can plug our anim set data table here and compile it back. But I think it still gives the error. So I think best approach would be first get rid of this thing, and let's manually attach our data table here. And if a row is found for this specific row name, so I'll promote it to a input. If it is found, then it will simply return. And this out row is having this specific structure now, and since it has this structure there, this output will be not a wildcard anymore. Therefore we can plug our anim set data table variable here, compile it back. Now you can see that error has been gone, right? So make sure whenever you plug these variables, go that specific sequence to first return that specific data structure there, and this wildcard output will be initialized to that specific data structure. And once it has been initialized, plug your anim set data table instance here, right? So there will be no errors. Okay, so this is the function to get a specific data record by using a specific row name from our data table, and we can use this helper function at our ABP locomotion, which is here, and let's call that function, which is get anim set. And I don't think we don't need a function like this. Instead we can make this function as PO. So PO functions always return a value without modifying anything inside of it. That's why it called as a PO function. So let's use that PO function here. So you can see for a PO function there is no execution pin. So you can simply call that function like this. And as the row name, we can use this ls anim set name, and it will return a specific outro. And I'll promote it to a variable and name this as ls set, and the category should be the locomotion system. Okay, so that's the first step for actually it's a long step, but that's the first step to have a reference from this BPC locomotion system to our ABP locomotion. Okay, and now since we have that reference, let's create another function called maybe set animation data, and let's use that set animation data to destructure our anim set record. So I'll promote this to a local variable called maybe L movement struct, right? Just for the reference inside of this specific function, in case this reference has been changed later on. So our local reference would be there. So I'll add the sequence, and here I'll get that local movement struct and break it, and this idle I can promote it to a variable called idle any. But I think we already have this any instance, so therefore I will delete this thing and let's reuse this specific idle any, and I'll promote it like this. Okay, maybe we can collapse this node as well, and I'll name this as set idle. So this will basically set the idle anim instance by referring to a specific data table record that is pointed by this specific anim set name. Okay, now I think I can clear this idle anim thing because it's just a hard-coded value for the testing purposes, and now we don't need it, and since we using our data table instance, it should be dynamically assigned. Okay, so let's play, and yeah, it's not initializing because we haven't called this set animation data function at our on set anim set event. So I believe it should come here like this, and now if I play, you can see that idle animation has been initialized. Okay, so now we have a data table oriented locomotion system schema where we are not manually assigning any sort of animation like that we did before. Instead of that, now we can simply define a record here and make the changes. So I'll show the benefit of having this data table. So maybe let's say I'll create a new record called pistol. So let's say this is a different anim set, and let's use pistol idle ready state. I mean pistol idle radius, and maybe let's have another one called maybe rifle, and there let's use rifle idle radius. So here you can see for unarmed we have a different idle animation. For pistol, we have a different one. For rifle, again we have a different one, but I believe this one should be MM, not the MF. So let's choose the proper one. MM rifle idle ADS. Yeah. Okay, so now we have three different anim states. So first I'll use this one. See, now we have unarmed anim, and if I go to my character base, select this BPC locomotion system, and I'll make this as pistol and play it again. Now you can see instead of the unarmed idle animation, it is now playing the pistol idle animation, right? So if I change this back to rifle, now it's playing rifle ADS anim state instead of the pistol idle anim. So this is the benefit of having sort of a data oriented pattern where we can easily plug and play different animation sequences and make it to alive, right? So this ABP locomotion system is now not hard coded. Instead, it is dynamically initializing based on the data definitions that we are provided at here, right? Okay, so that's the basic setup for the data oriented animation system or locomotion system. And the next tutorial, let's improve this further. And yeah, thank you.